Okay, taking notes here. We don't need to print out a worksheet or anything. We're just going to take these notes manually. So just put this into your notebooks. Okay, continuing with degrees and radians. Right, on the last assignment, you learned how to convert from degrees to radians or from radians to degrees. Okay, so these are the notes. This is actually part 2, right? Degrees and radians. The last assignment was part 1, so we'll just do this one part 2, and here's the notes, right? Notes. Okay, so we're pretty much going to just continue to become familiar with degrees and radians and kind of use this with what we previously learned. But again, when you learned this, you only saw this with degrees. So now you're going to see this with radians, and you're just going to pretty much go back and forth, right? From this language to this language, or from this language back to this language. So we're just going to reinforce that. It's going to be really important for you to do that. Okay, these first set of problems are going to say find the reference angle. All right, and we did that again just with degrees, but here they're giving you radians. So let's say number 1. They're asking you to find the reference angle for 7 pi over 6. Well, again, you're not too familiar with radians. This is a new unit of angle measure for you. So what you're actually going to do is first, right, every time for angles and stuff, you're more familiar with degrees. So what we're going to do is we're going to convert to degrees. We're going to solve it and get our answer in degrees, right? And then we'll convert it back to radians. So we're gonna start with radians. We're gonna work with radians. We're gonna start with radians. We're gonna work in degrees, and then when we get the answer, we'll provide the answer in radians. Okay. All right. So I have to graph this, but obviously step 1 is change this, convert this, and let's work into degrees. So convert to degrees. So that would be 7 pi over 6. And we learned that in the previous assignment to convert to degrees. So that's a pi here. So the pi goes here and the 180 degrees goes here, right? That's the conversion relationship. We learned to do that. The pi's will divide out. You're left with 7 times 180 degrees divided by 6. And then we know that the 6 and the 180 can cancel. So that'll be left with, these will divide, so you're left with 30, right? So 7 times 30, that's 210. So really 7 pi over 6 is 210 degrees. All right, we're going to work in degrees. So remember, step 1, or the first thing you're going to want to do is not work in radians. You're going to work in degrees. So we're going to convert this to degrees. This is 210 degrees. What do I do with that? Well, now you got to see this. You got to visualize this. You're going to draw it out. 210 degrees is, well, positive 210 degrees. Here's 0. Then here's 90. And then here's 180, right? So 210 has to be a 180 plus what? Plus 30 more, right? 210 degrees. I gotta go to 90. Another 90 is 180. And 180 plus 30 degrees. Everybody agree this is my 210 degree terminal side here. This is the angle here. All this, all the way to here. Here's my 210 degrees right there. But the question is, what's the reference angle? Well, remember, reference angle is the angle that is created using the terminal side and the x-axis. So this is your angle. This is your reference angle right here. The answer is 30 degrees. Your reference angle is 30 degrees. That is the correct answer, 30 degrees, but they don't want the answer in degrees. Remember, now we're working with radians. So all you got to do now is convert this, which is your answer, 30 degrees into radians. How do we convert 30 degrees into radians? Well, convert to radians. That would be 30 degrees over 1 times, and we're going to use the same relationship that we know, pi 180 or 180 over pi. Well, in this case, it's going to be what? Well, since degrees are in the bottom, that means that the pi is here and the 180 degrees is here. We know that the degrees cancel. So you're left with 30 pi over 180. And then the 30 and the 180 reduce, that'll be 1 over 6. 30 goes into itself once and into 186 times. So your answer is 1 pi over 6, or just pi over 6. And again, you can leave pi over 6, but you know that it's in radians, rad. So the reference angle is 30 degrees, which is equivalent to pi over 6. Let's do another one like this, number 2. What if they give you a negative 4 pi over 3, and you have to find the reference angle? Well, again, we don't want to work in radians. We're going to find out what this is in degrees. We're going to work in degrees. We're going to get the answer in degrees. And then you're going to answer it and convert it back to radians, right? So we're going to start with radians. We're going to end with radians. But the middle work and everything, all the thinking that you're doing is in degrees. Let's convert this to degrees first. So given the negative 4 pi over 3, convert it first to negative 4 pi. Negative 4 pi over 3 is in radians, converted to degrees. So that'll be, if this is pi here, then the pi goes down here in the 180, right? That's how we convert. We learned that last time. These all cancel out. You're left with negative 4 times 180 degrees divided by 3, but you can reduce here. 3 goes into 180 60 times. So negative 4 times 60 is negative 240 degrees. So negative 4 pi over 3 is the same as negative 240 degrees. Okay, I can do this in degrees. Let's draw this out. Remember, negative degrees. Remember, the initial side, all angles start here. Angles in standard position start here, 0 degrees. But if you go negative, remember that's clockwise. That's this way. So negative 240 is here 0. This would be what? Negative 90. And I keep going this way, so then now it's a negative 180. And how much more do you need? How much more do you need to get to 240? Well, 180 plus what? Another 60 degrees more. This angle, all this angle up here is a negative 240. Here's my negative 240 degrees. But what are we answering here? What is the reference angle? Well, if this is 60, remember this is 30, and we kept that practice. Which of these two is your reference angle? Terminal side with the x-axis. So that means that your 60 degrees is your answer. The reference angle is 60 degrees. That's the answer, but they want the answer in radians. So we got to convert. And we learned to do that as well. So how do we convert 60 degrees into radians? That's 60 over 1 times what? Well, if the degrees are here, that's 100, that's pi is 180. That's a conversion relationship that we learned. And you're going to get an answer of what? Well, the degrees will cancel. The 60 and the 180 will also reduce to 1 and 3. So your answer, 60 degrees, is equivalent to what? Pi over 3. That's the reference angle. Okay, so the first set of problems will ask you for the reference angle. Here's the second part. It's going to ask, actually, I'll do that in the next video.